Students, now we know how we can actually increase our fleet size. The concept which we know is for a homogeneous type of fleet sizing. That means same type of vehicles are added to your fleet. Now there could be a case when your fleet size would be non-homogeneous in nature. That means there are different type of fleets, there are different type of vehicles that can be added to your fleet. This model is actually a simple extension of a linear programming formulation of the homogeneous fleet sizing model proposed by White in 1961. So this non-homogeneous case would be an extension of that typical linear programming problem for the non-homogeneous case. Now for the model, the notations would be as follows. There will be xjk is the number of company vehicles of type K required on day J. Hjk is the number of hired vehicles of type K required on day J. So remember, K is the type of vehicle. That means 1 means it could be trucks, 2 means it could be trailers, and 3 means it could be some other vehicle. Djk is the demand for loads equivalent to the vehicle type K on day J. Big Fk is the fixed cost of a vehicle type K per day, whereas Vk is the variable cost of vehicle type K per day, and Hk is the hiring cost of vehicle per day of vehicle type K per day. So small h jk actually represents the number of hired vehicles of type K for a day J, whereas big Hk is the hiring cost. So hjk represents number, big H actually represents the hiring cost. The model, simple linear programming, extended linear programming model would be as follows. We would minimize a z function that would be a sum of j's into the product of sum of k's xjk into fk plus vk plus big hk sum of all the k's for small h jk. So what we will be minimizing the total hiring cost, total fixed cost, and total variable cost along with the number of vehicles which we are using. As it is a linear programming problem, so we would have two important constraints for it. Our xjk plus hjk should be greater than or equal to djk for all jk's. We cannot have, it should actually satisfy the total demand, the number of vehicles which we have and the number of additionally hired vehicles, the cost for it. The number of vehicles which we have and the number of vehicles which we hire on a day of type K should actually satisfy the total demand djk. And xjk and hjk should be greater than 0. This is the integrality constraints, and both should be integers. That means number of vehicles which we have plus the number of vehicles which we hired are actually discrete in number. They are integers and should be greater than or equal to 0 for any number that is j and k. So the first constraint actually ensures that each day all loads are carried by the appropriate vehicle type. So what was our first constraint? All the demand is actually satisfied through different type of vehicles, whether they are with us or whether they are hired additionally. And the second constraint actually represents the integrality of the decision variables, that our decision variables x and h should be integers. Thank you.